All right, Monarchs, welcome to the second video for lesson 3.4. We are solving inequalities in word problems. So in the first video, we did examples 1 and 2. We went over how to break them down, what we should be underlining, what we should be highlighting. And now we're going to move on to example 3. So if you have not watched video 2 for lesson 3.4, please go back and do that. Or video 1 for lesson 3.4, I'm sorry, go back and do that now because this is video 2. All right. So example 3 is a little bit longer, so we're going to have to unpack it a little bit, okay? I'm going to use a different color. All right, so it says your school carnival charges $2 for admission and 50 cents for each game. So I'm going to underline both of those because those are numbers. Actually, I'm going to highlight $2 for admission, okay, and 50 cents for each game, okay? You go to the carnival with $5.50. So we go to the carnival with $5.50. Write and solve. So we are writing and solving an inequality that represents the possible number of games we can play. Okay. So this is what it is asking us to do. So I'm going to underline it. And then this last part is asking us for the answer. It wants to know the maximum number of games we can play. So that's when we will solve that. That is what we'll figure out. Okay. So we kind of need to think about this one, right? So it's $2 for admission. So regardless, we are going to end up paying $2, right? At least $2. So we know regardless of any game we play, it costs $2 to get in there. So we are going to pay at least pay $2, right? So we're going to have $2. This is our price to go to the carnival. So we have $2 plus, okay? It is 50 cents for each game we play, okay? So it's 50 cents for each game we play. So it's going to be 0.50. And then we don't know how many games we're going to play, right? Because it's 50 cents for each game. We don't know how many games we're playing. We're trying to figure out what the maximum number of games we can play is. So when we don't know something, when we don't know what a number is, we use a variable, right? So this time we're trying to figure out how many games we can play. So I'm going to use G as my variable, okay? It's $2 plus 0.5 G, and it has to be, we cannot go over 550. We can spend $5.50, but we cannot go over that. So it has to be less than, okay? But we can spend 550, okay? So it's less than or equal to, because we can spend that exact amount. We can spend 550, 5.50, okay? So this is our inequality right here, all right? So I'm just gonna draw a line to that space because that's where it wants us to write our inequality. This is our inequality right here. This is what we need to solve. Okay, we have $2 for admission, 50 cents per game, and we cannot spend more than 550. Okay, so this is the inequality we are going to solve. So we need to get G by itself because once we figure out what G is, that's the number of games that we can play. Okay, so the first thing I want to do is move what is not attached to my variable. That would be this 2, right? So it's a positive 2 right now, so I'm going to do a negative 2 and subtract it from both sides of my inequality sign. Okay? So when I subtract it from this side, that cancels out, so I'm left with 0.50, or just 0.5 times games is less than or equal to 550 minus $2 would give me 350, or 3.5. Okay, so now I have 0.5 G is less than or equal to 3.5. Okay, so we have 0.5 G is less than or equal to 3.5, which means that 50 cents per game has to be less than or equal to 350. So basically we have $3.50 that we can spend on games, but we need to figure out how many games we can play. So this 0.5 is multiplying my G. So I know that when something's multiplying, I have to do the opposite. The opposite would be division. So I'm going to divide both sides by 0.5. Okay, I'm going to divide both sides by 0.5. That cancels out. Games less than or equal to, and 3.5 divided by 5. Let me do it on my calculator really quickly. 3.5 divided by 5 would be 7. So G is less than or equal to 7. So what does that mean? That means since G represents games, we can play up to 7 games, okay? So our solution is G is less than or equal to 7. And so the maximum amount of games I can play is 7, okay? So now we want to write our sentence. We say, we can play 7 games at the carnival. Okay. So that one was a little bit complicated, but we kind of just had to break it down and figure out what was being asked of us. Pick a variable that represented our games and then solve the inequality once we set it up. Okay. Thank you guys for tuning in. Stay tuned for the next homework help video for worksheet 3.